So we are going to talk about logistic function today. All right, let's look at the logistic function a little bit. You have to memorize this formula. If you don't, you won't be able to create the equation. So what you want to do is kind of remember how, like the little patterns of it. So you can see that there is a times b to the x, which is the same as your exponential function, right? And the difference is that there's a 1 plus in the front, and the whole thing goes in the denominator. There is a c on the top. This number means limit to growth. Okay, when it's in this form where this part is a 1, so this is kind of the critical part. If that part is a 1 and you have a 1 plus some kind of exponential function with a c on the top, c is the limit to growth. That means that's the highest point this y can be. That means that is the horizontal asymptote. Okay? Only when this is 1. When this is not 1, things change. This may not be the limit to growth. So please be careful. This is only C is only the limit to growth or the horizontal asymptote when this part is 1, because you're going to have questions where this is not 1, and then that number is not the limit to growth. So please be careful. All right, let's look at this question. Find the equation for the logistic function that satisfies initial value of 10. Limit to growth, which is the cap, is 40, passes through 1 and 20. If you look at this equation right now, how many coefficient or how many things do you need to solve for in order to have a complete equation? How many unknowns are there? I guess that's the question. How many unknowns are in this equation? 3. There are 3 things you don't know, right? A, B, and C. You don't know A, B, and C. So how many independent equations do you need to solve this A, B, and C? 3. You need to somehow find 3 information to help you solve A, B, and C. So looking at this question, are there 3 things I can use to solve this A, B, and C? Yes, I have an initial value. That's probably going to help me create 1 equation. I have a limit to growth. That's the second thing. And then I have a passing through 120. So those 3 things are going to help me solve A, B, and C. However, one of them actually already told me what A, B, or C is. Can you guys figure out what that is? Yes, limit to growth. They already told you limit to growth is 40. That means C is 40. Now let's talk about initial value. Initial value, what does it mean? At the beginning, it's 10. That's what it means. At the beginning, it's 10. So what does that mean? What does at the beginning mean? Not quite A, but it's kind of close. When something is equal to something. Yes, when x equals to 0. So when x is equal to 0, this number is 10. That's what it's saying. When x is equal to 0, this y value is equal to 10. And then we also have this number on the right, 120. That means when you put in 1, you get 20. So when you put in 1, you get 20. From here, with all this information, we need to solve for A, B, and C, but we already know C, so we just need to find A and B. All right, we're going to plug all those numbers in. Let's plug this one in first. F of 0 equals 10. So we know C is 40, so we're going to put 40 in, over 1 plus A we don't know, B we don't know, X is 0, and this whole thing has to equal 10. Okay, how do I simplify this? B to the 0 is 1, very good. So 40 over 1 plus A equals 10. Now what? Yes, multiply by 1 plus A, so 40 equals 10 times 1 plus A. All right, I'm pretty sure you guys can solve this now. Go ahead and figure out what A is. Actually, before you solve for A, or if you're in the midst of solving for A, there's a faster way to solve it and there's a slow way to solve it. The slow way to solve it is distribute the 10. So if you were distributing, that would not be a fast way. The fast way is to divide by 10. So 4 equals 1 plus 8, and then the fast way is just to subtract 1 from that point on. Which you need to kind of know this trick, because later on when we get into really, really complicated stuff, you really don't want to distribute. When you distribute, you make it twice as hard. Okay, so A is 3. All right, how do we find B then? What is the last piece of information we can use to find B? A equals 3, and then C equals 40. Huh? Yes, the last point, yes. So we put in 1, we get 20. So that means the equation 40 over 1 plus, we already know A is 3, so put 3 in. B we don't know. To the first power is equal to 20. All right, go ahead and solve for B. So again, use the trick I just showed you so you don't make it twice as long to solve. Okay, Mark, do you have B? 1 over 3. All right, so then the equation is f of x equals 40 over 1 plus 3 times 1/3 to the x. Okay, let's have you practice one. Let me know when you're done. Okay, the answer is f of x equals 60 over 1 plus 4 times 3/8 to the x. All right, we're going to temporarily go back to exponential functions. Okay, so this question says, determine whether the exponential function is a growth or decay function. Then determine whether the determine the percentage rate of growth or decay. All right, so kind of think back about yesterday. Is this a growth or decay function? Remember, growth. How do you know it's growth? What is greater than 1? The base. Yes, if it's bigger than 1, it's going to grow. The question is, what is the percent of growth? So how much is it growing by? What you do is you kind of use this really quick formula, which is base is equal to 1 plus r, r being the percentage of growth. It's very easy to understand. So the base is equal to 100%, that's how fast it's growing right now, plus how fast you're actually going to grow. Okay, so 1 just means 100%. So we have this base here that is 1.0064. So that's 1.0064, that's the base. So if I subtract 1, sorry, this is very messy. So if I subtract 1, so r is equal to 0.0064. What is the percentage of growth? Yes, 0.64. Please make sure you actually change it to a percent and not put 0.0064%. That would be a very, very small number. All right, so that's that. So let's go ahead and have you figure out growth or decay and by what percentage. Please be careful. When we are doing percentage, people tend to make a lot of mistakes. Please be careful and actually look at percent and not the number. Okay, let's start with Trey. Number 1, growth or decay?
Decay.
Andy, what percent? What number? Yeah, 1.42. So if you say negative 1.42, that's fine too. Negative just means it's going to decay. So if you already said it's decay, then it's not necessary that you put negative, but you could. Number 2, Evan, growth or decay? Josh, what percent? Yes, 96%. So please be careful. All right. Now let's solve some problems. Okay, if they give you an initial value and how fast it's growing or how fast it's decaying, you need to write an exponential function that meets that criteria. So initial value of 5 means what? Oh, okay, so first of all, let's read the question. It's an exponential function, so we gotta write the bare bone first. Okay, initial value of 5 means what? A equals 5, or when x is 0, y equals 5, right? When x is 0, b is gone, so that's why a is equal to 5. Okay, so a is equal to 5. Increasing at a rate of 17% per year. Increasing at a rate of 17% per year. So b is what? 1 point, sorry, I thought. It's increasing, right? So it's growing. That number has to be bigger than 1. Okay, so first we got to turn this 17% into a decimal, right? So 17% in decimal is 0.17, yes? So base, since we're increasing, so we're growing, so we're going to take the base, and then we're going to add the rate. So it's 1.17. Okay, and then now the equation is y equals 5 times 1.17 to the x. All right, next. Initial value is 5 again. This time you're decreasing at a rate of 0.59% per year. 0.59% per year. All right, let's try this. McKenna, what number is A? Ashley, do you know what number is B? 0.99. Let's be accurate, or put all the numbers in there. 9941. Yeah, I know you're rounding. So since they tell us 0.59, we're just gonna put all the numbers in there. So first, make sure you do change it to a number, so 0059. And then since we're decreasing, we're going to take 1 minus the rate. Okay, 1 minus the rate. So 0.9951. So y is equal to 5 times 9941 to the x. Okay, last one. Try this one, everybody. Can someone tell me the equation? Yes, good. All right, now let's look at word problem. Suppose a culture of 100 bacteria is put into a petri dish and the culture doubles every hour. Predict when the number of bacteria will be 350,000. Okay, we gotta think about this. So this is gonna be exponential because when you double, so let's say you start with 1, the next hour will be 2. You double it again, 4, double it again, 8, double it again, 16. So it's growing really, really fast, and that's gonna be an exponential graph. From this information, can you tell what the initial value is? What is it? 100, because you start with 100 bacteria. Can you tell what B is? This is a little tricky. 2, because you're doubling. You're doubling, so it's like 200%. if you think of it that way. Every hour. So they want you to predict when it's going to be 350,000. So you're going to start with the equation, right? So you have a and b, so that's 100 times 2 to the x. 350,000. Where would that number go? Would it go into x or y? Okay, so 350,000 goes in here. 100 times 2 to the x. I'm going to solve that, right? What's the first thing you need to do? Divide by 100. Yes, please do not multiply 2 and 100 together. That would be wrong. Divide by 100, so just get rid of 2 zeros. 3,500 equals 2 to the x. Let's take out our skills from last year. How do we solve this? Huh? We can do the circle if it works, right? So if for some reason 3,500 is a base of 2, we can solve it. But I don't think 3,500 is a base of 2. So what should we do? Yes. Log both sides. Yeah. Log both sides. Can we only use log? We can move the x to the front. Is log the only one we can use? Okay, so kind of review. If we have a log, what is the base of that log? 10. Okay, that log is a base of 10 if there is no base. Is log base 10 the only log I can use to solve this? No, what else can I do? Huh? Natural log. I can use natural log. In fact, I can use any log as long as I do the same log on both sides. Okay, huh? ln is natural log. Yeah, that's another one we can use. We will use that later on. So let's just use base 10 right now. So like Yuna said, we're going to move this x to the front. That's one of the rules. If you put a log with exponent, you can move the exponent to the front. So log 3,500 equals x log 2. What's the next thing we do to solve for x? Divide by log 2. Yes. So x is equal to log 3,500 divided by log 2. Okay, now use your calculator. When you use your calculator, please be careful. Once you press the log button, it's automatically going to open a parentheses. You need to close the parentheses before you divide. If you don't, you're going to take a log of an entire thing and it's going to be wrong. All right, what is the answer? Yeah, around 11.77. So that's what is this? 11.77 hours. Yes, it's going to take 11.77 hours to get to 350,000. All right, last one. Suppose the half-life of a certain radioactive substance is 20 days, and there are 5 grams present initially. Find a time when there will be 1 gram of substance remaining. Okay, A is what? 5. B is, 1/2. Because it's a half-life. So if you start with, let's pick a nice number. If you start with 8, the next, what is this? Every 20 days. So after 20 days, it will be 4. After 20 days, it will be 2, and then 1, and then half, and then 1/4. Will it ever get to 0? No, because you're just dividing by half. It's going to get really close to 0, but never 0. Okay, this one's a little bit tricky because there is this 20 days. It's every 20 days you decrease by half. So when you write the equation, it's y equals 5 times 1/2 to the x, but over 20, because it's every 20 days. Now, do you have to put this 20 days in there? It depends. You just have to know what you're looking for, I guess. So it's every 20 days it's going to decrease by half. So if they're asking you how many days, so every 20 days there's a cycle, so you're putting the 20 days in. If you don't, you might be overestimating how many days or how many cycles of this is happening. Anyways, so this is how you do it when they're telling you there's a every something days. You have to divide by that part. Okay, so we have to predict when there is 1 gram left. All right, I think you guys can do this. Try it. Figure out how many days it takes to get to 1 gram. All right, so 1/2 to the x over 20 is equal to 1/5. We're going to log both sides. That tells me I can bring this down. So x over 20 log 1/2 is equal to log 1/5. Okay, now you're going to solve it. So you're going to multiply by 20 and then divide by log 1/2. So multiply by 20 divided by log 1/2. This is going to equal 46.44. Okay, last one. This is logistic function and we had to solve. All right, so there's this high school with 1,200 students and someone started a rumor and this is spreading logistically by this function. How many students have heard the rumor by the end of day 0? How do you solve this? Day 0 means what? Is 0 T or S? T. Yeah, S means student, so T is time. So S of 0 is equal to what? That's the question. So when T is 0, what is the answer? All right, we're going to have to solve the other one. Yeah, 30. Because this part is all 1. So just 1 plus 39, 40. So. All right, we're going to solve the other part tomorrow.